Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 220. Problem number 15, the very last problem on the page, on page 220. It is the very same problem that appeared in the first edition of the revised GRE. We have already solved every single problem from the first edition. If you're interested in watching the original solution, you will find the original solution on day number 95. Here we're simply going to redo it at a little bit of a faster pace. Here's how the problem goes. It says, when a positive integer n is divided by 3, when a positive integer n is divided by 3, we are told that the remainder is 2. They go on to tell us that when n is divided by 5, the remainder is 1. When it is divided by 5, the remainder is 1. The question simply is, what is the least possible value of n? That's the key part, least possible value of n. In other words, there are infinite different values of n that will satisfy these two criteria, these two conditions. The two criteria are that when you take this number and you divide it by 3, we have to have a remainder of 2. So when you divide n by 3, when n is divided by 3, the remainder is 2. That's the first condition. So here's our n, you divide it by 3, we have to have a remainder of 2. And the second condition that we have to fulfill is that when n is divided by 5, the remainder is, and we have to find one that works. We want the remainder of 1. We want the remainder of 1 in the second condition. Same exact number. When you divide it by 3, we get a remainder of 2. When you divide it by 5, we have to have a remainder of 1. And we are looking for the least possible value. Since we are looking for the least possible value, as I said, there are infinite different values that will do the job here. Since we are looking for the least possible value, the smart thing would be to ask ourselves, what's the smallest possible value that we can have here so that when you divide it by 3, the remainder is 2? Well, that's very simple. We know that when you divide 3 by 3, 3 is divisible by 3, obviously the remainder is 0. If you want a remainder of 2, the simplest, quickest, easiest way to force it to have a remainder of 2 is to simply add 2 to it. Now, this quantity does have a remainder of 2 because you forced it. 5 divided by 3 has a remainder of 3, a remainder of 2. For example, if somebody asks you, what is the least possible number, listen carefully, what's the least possible number that you can have, positive number that is, so that when you divide it by 107, the remainder is 3. You want to divide by 107 and you want a remainder of 3. The least possible number is very simple to find out, which is, we know 107 is divisible by 107. Of course 107 is divisible by 107, it will have a remainder of 0, but we want a remainder of 3. Well, that's very simple. Just add 3 to it. Now that quantity, 110 divided by 7, will have a remainder of 3 because we force it to have a remainder of 3. We design it in that way, and we design it in such a manner. Do you understand? So this quantity, 5 divided by 3, has a remainder of 2. Let's see what happens here. So our n in this case is 5, has a remainder of 2. Our n in this case is 5. Let's try the same n here, and here we are told that when we divide it by 5, it has to have a remainder of 1. So if n is 5, 5 divided by 5, or n is 5, 5 divided by 5, has a remainder of 0. We want a remainder of 1. When you divide it by 5, we want a remainder of 1. That won't do the job. That does not do the job. What's the next smallest number that you can think of, so that when we divide it by 3, it gives us a remainder of 2. Again, very straightforward. We know that 5 divided by 3 has a remainder of 2, so we simply take our 5 and add 3 to it. 8 divided by 3 will have a remainder of 2, because 8 divided by 3 is simply 2 and 2/3. There is your remainder. The remainder is 2. Now let's put in that value of n here. 8 over 5. Here's our n. N is 8. 8 divided by 5 gives us a remainder of 3. That won't do the job. We want a remainder of 1 when we divide it by 5. When we divide it by 5, we want a remainder of 1. This 8 gives a remainder of 3. That won't do the job. Let's go to the next one, which is simply the 8 plus 3 divided by 3. 11 divided by 3 has remainder of 2, because 11 divided by 3 is simply, this was 2 and 2/3, this is going to be 3 and 2/3. That 2/3, that 2 is your remainder. So now our n is 11. Let's put it in here. Divided by 5. And what do you suppose will happen when you divide 11 by 5? We will get a remainder of 1. Voila! Voila! I get so excited that I even spell it out. Voila! There we go. We found the bloody thing. The answer is 11. 11 is the guy. 11 is the smallest possible value of n, so that when you divide it by 3, it has a remainder of 2, but when you divide it by 5, it has a remainder of 1. And of course, if we keep on going, we're going to find more. There are infinite such numbers. There are infinite such numbers which will do the job. But when you divide by 3, it has a remainder of 2. When you divide it by 5, it has a remainder of 1. But we want the smallest one we found. The smallest one is 11. That's all. You want to do one more? Let's do one more, shall we? A bonus one. It doesn't appear in the book, obviously. In the book, they only give you one problem. Of course, we need more practice. Let's do one more. If you're done with this one, I'll give you a second to absorb it. The next question says, I haven't erased the problem itself, perhaps I can use most of the stuff again. It says when a positive integer n is divided by 5, the remainder is 3. Question is, what is the remainder? Oh, it's a different type of question. You see, we have to erase all this thing. This question simply is, what is the remainder when n plus 2 is divided by 5? Well, let's find out, shall we? Again, here they're not looking for the least possible value, so we can plug in any number that we want as long as it gives us a remainder of 3. But just to keep it simple, we're going to start with the smallest one. The smallest number that we can think of, so that when we divide it by 5 has a remainder of 3 is, well, we know we want to divide it by 5. We know that 5 divided by 5 is divisible by 5, of course, which has a remainder of 0. We want a remainder of 3. So the smallest possible value would be the 5 plus 3, which is 8. Now we take our 8 here and go to this scenario where we have n plus 2 divided by 5. Our n is 8. This is our n. Right here is our n. N divided by 5 has a remainder of 3. This quantity divided by 5 has a remainder of 3. Has remainder of 3. Question is, what's the remainder when you divide n plus 2 by 5? Well, n is 8, so it's 8 plus 2 divided by 5. It will be 10 divided by 5 has remainder of, I just realized that I had not put down the answer choices, has remainder of 0. The answer choices were so bit too late in the game to give you the answer choices, but there they are nonetheless. The answer, of course, is 0. And that will always be true no matter what value of n you put in here, because they're not asking for the least possible value. Any value of n. For example, instead of 8, can you think of another number so that when we divide it by 5, we had a remainder of 3? How about 18? How did I come up with 18? Well, that's very simple. We know that 8 divided by 5 has a remainder of 3. So if I add any multiple of 5 to it, 10 is a multiple of 5. So 10 is divisible by 5 evenly. 8 has a remainder of 3. Therefore, 8 plus 10 should have a remainder of 3. 18 divided by 3 has a remainder of 3. And here we have 18 plus 2 over 5, which is 20 over 5. And 20 over 5 has a remainder of 0. You see? And why is that? Why is the remainder 0 when you divide n plus 2 by 5? Well, the reason is very simple. The reason is very simple, very straightforward. Listen carefully. Here's the reason. We know that when we divide it by 5, the remainder is 3. When it's divided by 5, the remainder is 3. But if the remainder is 3 already, okay, listen. If the remainder is 3 already, and if you add 2 more to it, 1 and 2 more to it, now we get a 5 again. And what will happen when you divide this 5 by 5? The remainder is 0. That's all. The original quantity has a remainder of 2. By adding 2 more to it, now we have a remainder of 5. But you can't have a remainder of 5 if you're dividing by a 5. You can't have a remainder of 5 if you're dividing by 5. For example, it will be silly to say that 25 divided by 5, it will be silly to say that the remainder is 5. The remainder can never be equal to or more than what you're dividing by. If it's 5, we could have gone one more time. And now the remainder will be 0. I'll see you tomorrow, okay? Bye now.